What if I said barium fluoride? If I wanted to calculate the molar solubility of barium fluoride. What's the formula for barium fluoride? It's BAF2, isn't it? Barium's +2, fluoride's -2. Yeah, swap and drop. Can you guys write the little equation for how that would dissolve? So what you would write for the equation is BAF2 solid. That would dissolve as barium ions, and barium ions have a +2 charge, and 2 fluoride ions. Any questions on that? So I know I'm going to leave room here to fill in an ice table, but I know that my equilibrium expression, my KSP, can you take the bariums and the fluorides and write what the KSP would be? Yeah, because it's going to be what? Concentration of the barium ions times the concentration of the fluoride ions squared, because I have to use my coefficients. If I were to then plug stuff into that ice table, I know none of this is going to matter, right, because that's a solid. But I know I would have, what would it look like on my change line for the barium and the fluoride? It's x and 2x, right? Because the change line, I've got to use my coefficients. So at equilibrium, I'm going to have x and 2x, yeah? Now, when I plug them in here to the KSP, what do I plug in for barium? What do I plug in for fluoride? 2x, and then I have to square it. When I combine all of that, what do I get? I get that KSP is equal to 4x cubed, don't I? Because 2x squared is 4x squared times x is 4x cubed. So this one, when it says calculate the molar solubility of barium fluoride, I have to realize, oh, barium fluoride is BAF2, so it's not just x squared, its KSP is equal to 4x cubed. I'm still just going to solve for x, because x is still molar solubility. Go to the table, look up the KSP for barium fluoride. It is 1.7 times 10 to the -6. And then I solve for x. I got 7.5 times 10 to the -3 molar. We do another one? Yeah? Got a question? So, do this one. Calculate the solubility of magnesium hydroxide. How different, though?
60.3 pounds.
I got 58.32. What if it said calculate the molar solubility of chromium 3 hydroxide? I want to work it with you to get into the KSP and the X expression. What's the formula for chromium 3 hydroxide? What? It's CrOH3, isn't it? That's chromium 3 hydroxide. So, can you do this? Write what ions it would be. It's the chromium 3 ion and 3 OHs. So if there were an ice table here, and then I brought all that down into the KSP, it's not. It's going to be worked the same, but it's not going to be, it's not x squared, right? It's not 4x cubed. What is it? It is 27, yes, x to the 4th. Do you see it? Okay, I'm going to show it anyway because some people are frowning at me. So, nothing here, right? This would be x and this would be 3x, right? So when I plug it in, I would plug in x for chromium, 3x for the hydroxide, but I've got to cube it. What is 3 cubed? That is 3 times 3 times 3. That's 27. That's not 9. Common mistake is to make it 9. But that's just... So I'd have 27x cubed times x, which is 27x to the 4th. Y'all all on board with me up to there? So when the problem said calculate the molar solubility, I'm back to all I got to do is solve for x. Look up the KSP and solve for x. 3 times 2 minus 20. .2 times 10 to the minus 8 molar. Okay, to summarize everything we figured out, when we started off like with the silver chloride and the calcium carbonate, you guys saw that for those, KSP was equal to x squared. Anytime it's a compound and it makes this one cation and this one anion, it will always be KSP is equal to x squared. But anytime it's something where it dissolves as one of these and two of the other, then that always works out to be 4x cubed. Anytime it works out to be one of these and three of the other, then that will always work out to be 27x to the 4th. If it's going to work out to be one of these and four of these, I mean, I'll go ahead and tell you. What you end up, is x times 4x raised to the 4th power. You end up with 108x to the 5th. So just understanding that pattern saves you from having to write, how it ionizes and filling in the ice table, etc. But you can do that as well.